SS tables to read, because that ties in quite a bit with what compaction strategy is going to be most useful for your particular data model and read patterns. So when Cassandra goes to do a read, it could potentially have to read from every SS table in order to guarantee that it sees the most recent version of any given row. But it has a few ways of eliminating SS tables and knowing that it doesn't need to read them. So the first is that it can do a token range check. So if, for every primary or partition key, that gets hashed in Cassandra and you get a token back. Every SS table stores metadata about the min and max token that it contains. So it knows the full range of tokens that are contained in that SS table file. So when you do a read for a particular partition, it can hash that key, get the token, and when it's looking at an SS table, it can see if it falls within that min-max range for each SS table. And if it doesn't, it knows it can safely skip that SS table. It can also perform something similar. Yeah?
What's the relation between like the data table and the SS table? Like, is there one SS table per data table, or how does that?
No, there's multiple SS tables per data table. Yeah, it depends on how many you have, depends on the compaction strategy, but it's usually anywhere from 1 to 100 is typical. But I'll talk a little bit more about that. But yeah, it does only need to look at SS tables for a given table. Each SS table only contains data for one logical table, for one schema table.
Okay, so you don't put multiple data tables into one SS table.
Exactly, yeah.
And when the compaction runs, does it do it? It only does it on a specific.
That's only on a
table?
specific data table. Yes, that's correct. So similar to the token range check, we can also check the clustering key. So in the schema, in the primary key, the first column is the partition key. All the remaining columns are what we call the clustering columns, or the clustering key. And those control how we order the rows within a given partition, how they're ordered on disk. So for example, if you have something like a date that you're using for a clustering column, we know for each SS table the min and max date that it contains. So if we query only for say data in January, we can eliminate any SS tables that don't have data that overlaps with January. So this is kind of similar to the token range check, but it's just on a different part of the primary key. There's also the Bloom filter check. So alongside each SS table, we store a probabilistic data structure called a Bloom filter. And the Bloom filter allows us to ask a question like, is the partition with a given key in this SS table? And we get back an answer that's either no with 100% probability, or probably with, say, 99% probability of being correct. So the Bloom filter allows us to eliminate SS tables that, let's say 99% of the time, it allows us to eliminate SS tables that don't contain any data for a given partition. So notice that that's not for a specific row, it's just for, that happens at the partition level. So if you have wide partitions where you have many rows within one partition, this check is not necessarily as useful. And I'll talk a little bit more about that as well. Last, did you have a question? No. Okay, sorry. Last, there's a max timestamp check that we can do. So when Cassandra is going through and reading SS tables, it reads them in a particular order. So because of last write wins, we only want to return the version of a row that has the highest timestamps, because that's the actual current version. So when we read SS tables, we start with the SS table that has the highest max timestamp, and we move through to older SS tables as we go along. If we happen to read a complete version of the row, we can look at that timestamp, and we can skip any other SS tables that we see that have an older max timestamp, because they can't possibly contain any newer data for that row. We already have the latest data. So that's one way, or one final way that Cassandra can skip checking some of these SS tables. All right, on to the first compaction strategy. So size-tiered compaction is the default compaction strategy in Cassandra. It was the only original compaction strategy. It basically works by compacting similarly sized SS tables, and by default, it looks for 4 similarly sized SS tables. So what happens is, if you're performing writes, they get buffered in a mem table, they get flushed, you get an SS table. Once you collect 4 of them that are roughly the same size, Cassandra then goes, takes all of those, compacts them, and makes one larger SS table, and then it's free to delete all of those. And then, of course, once you fill up the mem table again, you get more small SS tables until you get 4 of them again. These all get compacted. We get another larger one, and this repeats until we have 4 of this size. Then these all get compacted into one very large SS table, and this sort of tiered pattern continues. So, and it's
So doesn't this kind of work against some of the strategies you use for like sifting through tables?
Yes, it does. It definitely does. Yeah, I mentioned right there, only the Bloom filter and the timestamp checks sort of help with this, and it's mostly just the Bloom filter one, because we're not discriminating by token range or clustering column range at all here. We're only looking at the size of the SS tables when we decide what to compact together. So it's mixing, any of these SS tables are likely to have data from the full token range and probably from the full clustering column range. So those first 2 checks that I mentioned usually aren't useful with size-tiered compaction strategy. The Bloom filter check still is pretty useful, but it depends on what your data model is. So like I mentioned here, if you've got a wide partition, that means you've got multiple rows per partition, right? Over time, you're inserting new rows into this same partition. So that means that every one of these SS tables that you write out is probably going to have some fragment of that partition in it. And so if we're looking for just one particular row in a partition, we'll go to do our Bloom filter check, but every SS table is going to have something from that partition, even if it's not the particular row we're looking for. And so we're going to have to actually go into the SS table and read to find out that that row doesn't really exist there. So even the Bloom filter check isn't that useful with size-tiered compaction strategy. The timestamp check can help a little bit because these new SS tables, the small SS tables tend to be pretty new. They haven't had time to be compacted into anything yet. So sometimes if we're reading a row that's brand new, we'll read a very new SS table first. We'll get the most recent version of the row, and then based on the timestamp, we can know we don't have to check the rest of this. But that doesn't always work. On the other hand, if you have partitions that only have a single row, so say something like a users table where your primary key is just user ID, in that case, your row and your partition can only exist in one SS table, assuming you don't update it. So in that case, the Bloom filter check will actually work really well because the partition only exists in one SS table. And so you're likely to only have to actually read one SS table if you're looking up a user. Definitely your data model affects how useful these checks are with size-tiered compaction strategy. Yeah.
So now I'm assuming like on spinning disks, once these SS tables get large,
Yeah.
I/O is just outrageous.
For reads?
Because you're compacting at the same time, you're
Yeah.
compacting 90 gigs.
Yes.
Yeah.
Yeah, definitely. I mean, spinning disks just suck for everything. Like, don't use them. There's no reason to use them. But yeah, it's you do start once you start to get really large data sets. You do spend a lot of time recompacting things, right? So if you've got, these might be 250 gigs each if you've got 1 terabyte of data. And so at some point in time, they're all going to be involved in one compaction, and Cassandra's going to have to spend a lot of time merging a terabyte of data and writing it out. So there can be a lot of extra work that happens, and if you have a very large data set, it can get painful with size-tiered compaction. And one of the other compaction strategies can help to address this a little bit, time window, but I'll talk about that a little bit. And it's also worth mentioning what I wrote there at the bottom. So you have to have at least half of your disk space free whenever you're using size-tiered compaction strategy. So imagine we wind up where we've got just 4 really large SS tables and we need to compact them. While it's compacting them, it's writing out the merged result, but it still needs to keep these around so that it can service reads until the compaction completes. So temporarily, we're going to have twice as much data on disk. And that's why you have to keep half of your disk space free with size-tiered compaction strategy. So that's one downside to using really large data sets with size-tiered as well.
So is there an application that this is even good for, say with SSDs?
Yeah, well,
Or do you, never mind, okay.
yeah. So it is pretty good for write-heavy workloads. It's pretty good at absorbing large amounts of data coming in. There's not a huge amount of write amplification. Usually you wind up, like I said, with about roughly a dozen SS tables, so 3 or 4 tiers. So that means that rows are only getting compacted about 3 or 4 times in their lifetime. So that's not a huge amount of write amplification through compaction. So it works pretty well for write-heavy workloads. Like I mentioned, it works pretty well for single row partitions in terms of servicing reads, because we only really have to check one of those SS tables. That assumes that they're infrequently updated. If you had a users table where you were constantly updating it, say something like last time accessed, then that single row would have different versions spread across lots of SS tables, so that wouldn't be quite as good of a fit. The other upside to size-tiered is that it's very simple and it's fairly robust. It's a lot easier to kind of screw things up with the other compaction strategies, but size-tiered, it works fairly well under a pretty wide variety of conditions. So in terms of tuning size-tiered, there's only really one. There's a few things that you can change, but there's only one that you ever really should change, and that's the min-compaction threshold. So that's the default for that is 4, and that's just how many SS tables it tries to group together for a compaction. It doesn't ever really make sense to lower that number, because you would end up doing a significant number of compactions. But if you don't need to compact your data as frequently, it can make sense to raise it. So again, if we had something like the users table, where we're almost never updating it or deleting things, and the data is practically immutable, there's not really a lot of point to compacting things, right? You only need to compact things if you've got an updated version or you've deleted it and you want to merge those two things. So if that doesn't really happen, you can compact a lot less often by raising the min-compaction threshold. So you can raise it to something like 6, and that'll cut down a lot on the amount of compaction work that Cassandra does.
If you have the opposite situation, perhaps like it was chosen erroneously, would it make sense to reduce it? Like, let's say if someone thought it was a good idea to use it for a session table that's just constantly getting, would it make sense to lower
The session table is constantly getting updated.
Yeah,
Yeah.
10-minute TTL.
Well, it might make sense to use one of the other compaction strategies as well, like level compaction. Depends on how frequently you're reading it. So if it's a session table, I assume that you're reading it roughly as often as you're writing it, or
Maybe one day.
maybe one day.
Yeah.
Okay.
So, isn't it better to reduce it compared to doing a full compaction? Say in a situation, I have 4 SS tables, 3 are in like 50 gig each,
Yeah.
and the other ones are small.
Yeah.
It's gonna take some time to catch up.
Yeah.
So isn't it better to do?
Yeah, that's a good point. That is one circumstance where it could make sense. So basically, he's saying, what if you really want to force it to do some compactions? Say you're running low on disk space, you've done a lot of deletes, and so you know there's a bunch of deleted data that needs to get compacted out. So one tool that people tend to use for that is a major compaction, which basically means you take all the SS tables, combine them into one really large one. That's problematic because in size tiered, if you wind up with one SS table that is like completely massive compared to everything else, it's going to be too large to ever naturally participate in another size tiered compaction. There's just nothing else is close enough in size. So yeah, one option instead of doing major compaction could be to lower the min compaction threshold, say just to 3, from 4 to 3, and that would spur it to kick off some extra compactions for a while, help you purge that deleted data, and then you could raise it back up to 4. That's a good idea. Sorry, I didn't mean to cut off your question about sessions, but I'll talk about level compaction, and we'll see if that addresses that. Any other questions on size tier before I move on?
So if you had like a lot of deletes, let's say in the first 4 small SS tables,
Yeah.
then it's possible like your combined new table could be only as small as one of those, right?
Yeah, absolutely. So say if you if this one was full of inserts and then this next one was us deleting everything in there, then when you compacted them, right away you would basically wind up with just this table, this SS table, and after enough time had passed, after GC gray seconds has passed, Cassandra is allowed to purge those tombstones, and so the next time that participates in a compaction, we can basically just drop everything in there.
So, going back to the tombstone topic,
Sure.
isn't there another check where it says 50% bucket and so on?
Yeah.
Can you elaborate on that?
Yeah, there's a specific extra type of compaction that Cassandra can do to try to just purge tombstones, and that's when it sees that an SS table has a certain percentage of it is filled with tombstones that are probably expired, and in that case it'll try to just compact an SS table like this one by itself. The problem is that it can't purge tombstones unless the data that's shadowed by the tombstones participates in the same compaction or has already been removed, right? Because if we just drop this and this SS table, say, still existed, all this data would become live again because we don't see that it's deleted anymore. So we have to make sure that all of this is gone whenever we purge these tombstones. So that special compaction doesn't work all that well in practice because of that limitation.
The tombstone only compaction is only from 3.8 something, right? It's not in 2.0. I mean 2.star.
That's a good question. I think it's been around for a while. I think it's been around longer than that, but I could be wrong. Yeah. Anything else on size tier? Okay, so level compaction. This was introduced in Cassandra 1.0, and it's quite a bit more complicated than size tiered compaction is. Leveled was basically implemented to address the problem of having to read a whole lot of SS tables every time. So leveled compaction strategy basically does a lot of extra compaction in order to guarantee that we can read from a smaller number of SS tables. So I'm going to have to do some diagrams to explain how this works. All right, so once again, we'll start out with our mem table. Whenever that gets flushed, it goes into a special level called L0. And there's nothing, L0 basically doesn't have any special rules. SS tables, they can overlap, they can be any size. It's just a temporary holding space until we can properly integrate them into the normal levels, L1 and up. So in L1 and up, we restrict SS table sizes to be 160 megs by default. And in L1, let's see here, L1, we can have 10 of these. Roughly 160 megabytes each, so a total of 1.6 gigs in L1. For L2, it's a similar setup, but we can have 100 of them. There's still 160 megs, but we hold 100 SS tables in L2, and so we can hold up to 16 gigs. And as you might guess, L3 continues this pattern, but with up to 1,000 160 meg SS tables. So the special thing about leveled compaction strategy is that in each level, the SS tables don't overlap in terms of the tokens that they cover. So it's back to the partition keys, right? No partition can exist in both this SS table and some other SS table in level 1. So if we're only reading a single partition, we only have to check one SS table per level. And since we get pretty quickly up to large data sizes in these levels, we're only going to really need to have maybe 4 levels that we could potentially check. So that's a max of 4 SS tables. So this having to only check 4 SS tables instead of 12 or 15, like in size-tiered compaction, is a lot more efficient. But in order to maintain this structure, level compaction has to do a lot more work. It's compacting a lot more frequently. So the way that the compaction works is, say we get something flushed into L0, we want to integrate it. So we are going to move it into level 1 to start out with, and we need to compact it with every SS table that it overlaps with. And since L0, there's nothing special about the SS tables, it probably covers the full token range, or roughly the full token range. So that means that it probably intersects with all the SS tables in L1. So we're going to involve basically all 10 of these with this L0 compaction to start out with to get it integrated. Once L1 fills up, we need to move some of these SS tables into L2. So say that L1 is full and we decide to move this SS table into L2. We need to compact it with everything that it intersects with in L2. But fortunately, since this is already restricted in terms of the tokens that it covers, we'll only have approximately 10 SS tables in L2 that we need to compact it with, instead of compacting with all of L2. So it kind of sucks that we have to compact it with 10 SS tables in both of these cases. That's a lot of extra work, but it's not as bad moving from L1 to L2 as it was putting L0 in. L0 has a few special behaviors. If it starts to get really full, I think it's if it has over 32 SS tables, it'll switch to using a size-tiered compaction strategy just within level 0, and that's just to keep the number of SS tables down. The reason why that's important is when we're doing reads, in addition to checking these, we also need to make sure that we read anything in L0. And since SS tables in L0 have, maybe the full token range, we don't, we're much more likely to have to read everything in L0. So if there's a large number of SS tables in L0, that can slow down reads a lot. So that's why we sometimes perform compactions on L0. Let's see here. Yeah. I was gonna say, yeah, it compacts to the highest levels first, but that's not, that doesn't really help you understand anything, so. Yeah.
On LCS, so if I have, say 200 plus tables, SS tables,
Yeah.
how will I know that it's in L1 or L0 or L3, what level is it on? Like for size tier, I know that if you look at the size, I know similar size or whatever.
Yeah, there's a certain tool to do that, but I can't.
Is this table info or something like that?
Yeah, there's like a no tool
Compaction
command.
stats? I don't-
Not compaction stats, I don't think. That just tells you about what active compactions there are. Yeah, unfortunately, I can't think of the name of the tool off the top of my head.
Okay.
Yeah, but I know there is one. I just can't remember the name.
Okay. At LCS, you mentioned it's for read heavy or write heavy type activity.
Yeah, so it's for read heavy.
Oh.
Absolutely, because as I was pointing out, the main advantage of this leveled structure is that we only have to check one SS table per level at most. So reads are a lot more efficient with level compaction strategy. The downside is that level compaction does way more compaction work than size tier does for the same amount of data. The write amplification is much higher with level compaction strategy. So if you're dumping a lot of writes into level compaction strategy, Cassandra's going to have to do a lot of extra work, and it's not going to be worth it. You really only want to use level compaction if you've got a pretty read-heavy workload. That's the only time when the trade-offs are in your favor. It tends to be more helpful whenever you have a lot of updates. So when your row normally and size tiered would be spread across a lot of SS tables, or would have different versions across a lot of SS tables, and leveled, those are going to get merged together into one SS table much more quickly. The same thing is true for deletes as well. When not to use LCS or what not to do with it, bulk inserts. So that's mostly related to level 0. So if you suddenly dump a whole bunch of data into a level compaction strategy table, you're going to fill up L0 with lots of SS tables. And it's going to take a while for those to get processed. And while those still exist in level 0, we're going to have to read most of them on every read. So reads are going to slow down a lot while level 0 has a lot of SS tables in it. And that's why you don't want to do any big bulk inserts while you've got active reads on level compaction strategy. Let's see here. In terms of tuning level compaction, you can adjust the SS table size, but it's generally not a good idea to do. So in terms of tuning it, there's not really a lot of useful knobs to turn on it. Any questions about level compaction before I move on to time windowed?
So the 160 megs advice is just to stick with that.
Yeah, I'd recommend sticking with that. We did some benchmarks on various SS table sizes, and there's a trade-off between write amplification and the number of SS tables that you basically need to read, and or the number of levels that you have, right? So if you have much larger SS tables, you wind up with a lot more write amplification, but you can potentially have fewer levels. The trade-off seems to have a sweet spot around 160 megs, so that's why we left it there. Any other questions on leveled? Did that answer your question about sessions? hopefully.
You know, I'm probably too ignorant to get an answer yet, but
Okay.
we're just paid Mike Brummett like $48,000 to send some guy down to fix the problem.
Okay.
So
Okay.
by end of month it will be fixed.
Okay, okay.
Is there any change in the property or the features in DC50?
Around level compaction?
Yeah.
Probably. There's been a lot of tickets throughout the entire lifetime of level compaction. A lot of changes around how we deal with level 0. Things like anti-compaction if you're doing incremental repair. I don't normally work on compaction, so I'm not super familiar with the tickets that are recent. But if you want to look really in depth at those, at the 2016 Cassandra Summit, Wei gave a talk on level compaction that does have some more detailed info, and it also has a big long list of important tickets to take a look at. So I would search for that if you want to really get into the nitty gritty of level compaction. Okay. So time window compaction. This is the most recent compaction strategy addition to Cassandra. It's a better version of something called date tiered compaction strategy that was introduced in like Cassandra 2.1, I think, maybe 2.0. So time window compaction strategy is basically, it's ideally suited for time series data. And it addresses a lot of the shortcomings that that size tiered compaction strategy has when you've got a more time series oriented data model. So I have to diagram pretty much all of these out a little bit. All right, so the way that time window compaction strategy works is we're only going to compact within a time bucket. So say something like 1 day. So say in our, while we're writing, we're always writing SS tables out to the current open time window. Once that time window closes, we're going to compact all of these SS tables together into a single one, and then we're never going to compact it again. So as you move back in time, for each time window, or each day, if we have it set to a day, we just have one SS table. And while the window's open, we're performing size-tiered compaction strategy in it. But the most important part is that we don't compact anything after the time window closes. So, yeah, just to make sure, if y'all aren't familiar with time series data, that's basically any time that you're using a timestamp or something similar for your clustering column, and you're interested in querying your data by time ranges. So this is typically things like user logs or sensor data, things that are coming in sort of a time order, and you're interested in what happened during this time window. So that's important, and that fits really well with time window compaction, because if you remember the clustering column check that I talked about, with time series data, you're normally using a timestamp for the clustering column. And since in time windowed, we're restricting these by the day, our clustering columns are only going to span 1 day worth of time, roughly speaking. So if we need to, or if we want to query data from a specific day, like Tuesday, we can easily tell that we only need to look at the SS table that corresponds to Tuesday, and we can ignore everything else. The other reason why this works really well for time series data is that it's normally immutable, right? Once you get that piece of data in. You're basically never going to update it. You're probably not going to delete it. Maybe you'll TTL it. But you don't ever perform a real update of it. So there's not ever going to be multiple versions of it spread across these different windows. So there's no reason why we would ever want to compact these two SS tables together, because they don't affect each other, right? There's no newer versions of data in this table that's now in that. So we avoid doing a whole bunch of extra compaction work because we know that it's not useful at all in this case. So instead of deleting the data with time series, it's pretty common to use a TTL, a time to live, right? So after a certain amount of time, the data just expires and you don't have to explicitly delete it. The reason this works really well with time series or time windowed compaction strategy is say you've got a TTL of 30 days. Once you've got an SS table from 31 days ago, the entire thing has expired. And we can just drop the entire SS table at once. We don't have to perform any compactions in order to purge this data. So it's extremely efficient to purge expired data that uses TTLs with time windowed compaction strategy. Let's see here. What else was there to say about this? So just some general advice about it. You don't have to do a lot of tuning with this either. There's only sort of one main parameter, and that's the size of your time buckets. So good general advice is to align this with however you're bucketing your partition keys. So normally with the time series data model, you don't want partitions to grow endlessly, right? Say if you're tracking all the activities for a specific user, you don't want to necessarily endlessly append those to one partition because it might eventually grow extremely large. Instead, you'll want to break it up by some time unit. And so it's very common to do one partition per day or per week or per hour for time series data. And it makes sense to align your time buckets in time window compaction strategy with whatever you're using for your partition keys. So if you're splitting up your partitions by day, it's a good idea to use one day for your compaction strategy as well. So that way you basically just end up with with your partitions only spanning one SS table or maybe two SS tables. And so that way the Bloom filter checks also are useful here if the clustering column range check doesn't work for some reason. So you also need to be kind of careful in time windowed compaction strategy about one thing, and that's out of order writes. And by out of order writes, I mean writes that have a write timestamp that is significantly older than the current timestamp. Or if you're talking about sensor data, something where the clustering column timestamp is much older than everything else that you're inserting. The reason is that that'll basically, so if we're inserting new data and then we suddenly say replayed some failed inserts from last week, then this SS table is going to have a mixture of brand new data and data from 2 weeks ago. So whenever we go to say read data that we think is from 2 weeks ago, we're going to have to check our normal expected SS table back here, and we're also going to have to check this one. So that's twice as many SS tables that we need to check during our read, just because we had some out of order inserts. So basically, you want to try to avoid really delayed writes. You want to avoid writes that are delayed by more than your time bucket length. So there are a couple of strategies for dealing with that if you absolutely have to. One of them is to explicitly, before you replay those failed writes, to pause your normal write mechanism, force a flush, insert your old data, flush it, and then resume normal writes. So what that effectively does is you end up with one old SS table and one new SS table. That kind of has limited effectiveness, but it's better than mixing them. Other than that, there's something you can do with SS table loader, but I don't know that too well off the top of my head, and so I'm not gonna go into that. But let's see here. But time windowed is basically, it's amazingly ideal for time series data. It removes all of the problems that side-steered compaction has of compacting data that doesn't need to actually be merged together. And so if you have a use case that's even a pretty good fit for time window compaction strategy, I definitely recommend giving it a try. Even if you don't have time series data, it can still work pretty well for other use cases. So say we do have something like the users table, and say that data is effectively immutable. We never update users, we never delete them. In that case, we know that there's never going to be any updates to that row, so we know that there's no point in compaction merging SS tables together, because it's never going to merge multiple versions of a row. There's only one version of that row in existence. So compaction is sort of wasted effort in that case, and we can more or less just turn off compaction. And time window compaction strategy is kind of effectively turning off compaction. So it can work reasonably well for that use case. It does absorb heavy writes and deals with reads quite effectively, as long as you sort of follow the rules around ordered writes. And like I said, for TTLs, this is by far the most effective way for dealing with TTL data. Side-steered compaction doesn't work that well because we're always mixing old and new data together in compactions, right? So we're never going to have a fully expired SS table. The only way that we can remove that expired data is by performing a normal compaction. So it's a lot more expensive to drop TTL data in the other compaction strategies. All right. I think that's everything I had about time windowed. Yeah.
So on those delayed writes, you end
Yeah.
up with an old and a new, but that's the old date and the new date, right?
Yes.
So the old date wouldn't get,
Yeah, I was trying to remember.
Impacted with
There's
the-
some special behavior that I'm having trouble recalling exactly now about how it detects that case and how it deals with it. Yeah, I might need to double check that and give you a better answer after the talk. Any other questions on time windowed?
I think in the newer version, there is a side-steer compaction inside time window.
Yeah. So it definitely does that for the open window. I think the change that you're referring to is that what I believe happens is, in this case, it detects that this is supposed to be in a different window, and it'll perform side-steered compaction with this in the correct window. But the details of that are escaping me at the moment. So yeah, that was a relatively recent addition as well.
Yeah, it was helpful so at one of the projects, we had 150,000 writes per second.
Okay.
Even small window. used to get like 1,000 SS tables.
Yeah,
So this was very helpful.
yeah. So now it'll just perform. Basically, what it does is it performs size tiered compaction while the window's open, and as soon as the window closes, it switches to just doing one major compaction of the entire window, and that's how it produces the SS tables now. Anything else on that? Cool. Okay, so just to summarize about when to use each of these. Size tiered, it's really good for write-heavy workloads. It's the most foolproof compaction strategy. If you don't know for sure that you can use one of the other two, that's the one you should stick with. Leveled is really good for read-heavy workloads, but you have to be very careful that you don't overwhelm it with writes, because that's easy to do as well. And then time windowed, it's perfect for time series data. It works really well with TTL data, very static, immutable data as well. Compaction strategy is also pluggable, so technically if you have a really brilliant idea for how to handle something in a custom way, you can do that too. And that's actually how time windowed compaction strategy started out. So it is possible to do it. I think time windowed has been, I can only think of 2 people who have ever had actually a good idea, so it's pretty unlikely, but it's possible. So that's basically it for my talk. So if y'all have any general questions about compaction or anything else.
What about migration?
About migrations?
Yeah, LCS to STS.
Yeah.
What's the best way? So the thing is, the current project, one of the production table, before I started, somebody used that as LCS,
Yeah.
thinking that it's going to work out. But I noticed that the read to write ratio is 1:4,
Yeah.
and now we have like 200 SS tables.
Yeah.
So I want to migrate that to STCS.
Yeah. So what I would recommend is this. You can actually change the so normally the compaction strategy is set in the schema at the table level. And so if you change it there, it affects all nodes at once. What you can actually do is through JMX, you can change the compaction strategy for a single node, for a single table. And so what I would recommend for a migration like that is to do it one node at a time. Go in through JMX, change it from level to size tiered, wait for all the compaction to settle down, and then move on to the next node. If the impact of doing that is too high, I would turn off gossip and RPC and all of that on the node. Essentially, have it running without communicating with anything, and then perform the switch. So that way, it's not servicing any of your reads or writes, and it has time just to migrate over the compaction strategy before you turn those back on.
So you effectively taking the node out of the ring.
Yeah, you'd effectively be taking it out of the ring for a while it does handles all the compaction. Exactly.
The right server equals true. Start up the node with the right server equals true. That will disable writes to that node.
Yeah. You can also just restart it with there's a JVM parameter, join ring equals false, and that would work as well.
Okay.
Yeah, that's what I would recommend for that. Other general questions about compaction?
So do you know of any way like to force a compaction, like leveled compaction using JMX? I know like for the size tier,
Yeah.
there is a JMX option to manually start a size tier compaction.
Right.
But for leveled, I didn't see any option. So
Yeah. So there is a relatively recent ticket that's designed to provide something along the lines of a major compaction. So with size tiered, it's really clear what a major compaction is, right? It means compact all the SS tables into one. That's not as clear with with level compaction, because you still need to maintain all of these levels, and you can't just produce one big SS table. So there's a new tool, and if I remember correctly, it tries to essentially create a good new leveling. So I think in the case that, say you had a bunch of data in level 0 and it would take forever for that actually to go through the normal steps and everything to get adjusted in the levels. I think what it does instead is it tries to plan out an appropriate leveling and sort of do all of that work at once. Cannot remember the name of.
Does it require a latest Cassandra, or it works with the?
I think that was introduced in like 3.6. So yeah, I think that would require the most recent Cassandra in that case.
I mean, the main reason like we want to force a compaction is for this tombstones thing.
Yeah.
Like if there are like more tombstones and we have a 2-day GC grace, so like they are occupied and
Yeah.
the reads are slow, so we want to clear them off, and then the compaction will not trigger, and then we want to force sometimes.
Yeah.
And then most of our tables are leveled, so we can't.
Yeah. Yeah. Unfortunately, for something like a 2-day GC grace seconds, that's kind of tough. I mean that might be a case where having larger SS tables might be better for you because it reduces the number of levels.
Mhm.
So the problem in level of compaction is that tombstones will end up in the top level, and the rest of the data that it shadows, it takes a while for that to actually to always end up in the same level as well. And so that's why your tombstones are sticking around for a while and not being purged. Yeah, I'm not sure off the top of my head what to suggest for
Do
that.
you know of any way like where people are avoiding tombstones totally, like for deletions just because of this? Like some other way to avoid tombstones and then some other way for deletions.
Yeah. So TTLs if you
That
can
will
use.
also create a tombstone record, right? At the end of the day, I mean after the TTL is expired.
No, after the TTL is expired, it's free to just purge it.
I thought it creates a tombstone after the TTL.
I think it does because you could have inserted the
Yeah.
row without a TTL before.
Yeah, that's right. That's true. Yeah. Yeah, there's something special about that, but I can't think about it. I can't think of it right now. Some people use a setup where they have a set of rolling tables.
Yeah.
So then they would
I
switch to a new table and then truncate after 2 days instead. So that's
so during compaction, like it checks the rules and then only like it promotes the row depending on the rules. That's what you're talking about, right?
for level compact. No, I was talking about so if your entire data set turns over every 2 days, like if everything gets deleted periodically, yeah, then some people will every 2 days they'll switch to an entirely new table and start writing to it, and once the data in the previous table is old enough, they'll just drop the entire table or truncate it. So that's one option. Yeah, unfortunately, deletes are one of the things that sometimes you have to think about a lot in Cassandra, because it's a log structured merge tree, and because it's distributed deletes have particular properties. Like that's why you need GC gray seconds, is because it's a distributed delete. So yeah, it can be a little bit tricky sometimes to deal with deletes. Anything else about compaction? All right, cool. Thank you.
Hang on, bring more pizza.
Yeah, let me see if I can find the ticket about that special LCS compaction.
Oh, does anybody need a parking validation? Maybe a parking.
That's fine, forget it. That's good. That's fine. Keep it consistent. Yeah,
Sometimes we trade meetups, so I think sometimes he goes to Python meetup.
I've been using
Some other meetups, sometimes like Apple Factories.
Okay.
I mean, like,
Use it like you just haven't ever seen it.
taking advantage of stuff to.
Tyler, right?
Yeah.
Yeah.
Yeah, hey man, I'm Tom.
Tom, nice to meet you.
Yeah, I'm working at a place called USA.
Okay.
Kinda,
Started a city.
Yeah.
and we're like super new.
Okay.
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 And unfortunately we're on some like 486 or something ancient version.
Okay.
We're using like a CA tool that doesn't work with Cassandra 3.
Okay. Okay.
And so anyway, like even I've watched like every video that you guys have out there. Like
Okay.
I call it like Patrick McFadden. I feel like he's like my second uncle, and you know like Jamie King and like all those guys.
Okay.
I've seen all their stuff.
Okay.
But I'm very concerned about something.
Okay.
And I was hoping you put my mind at ease before we get our guy to come down and help us out.
Okay.
Everything that we're storing is TTL.
Okay.
I have never ever completed a repair.
Okay.
Like we have DSC. You work at DSC?
Yeah. Yeah.
Okay, so you're familiar with like Health Center and all that.
Yeah. Yeah.
So you know there's like the repair service.
Yeah.
That thing is running like full bore all the time.
Okay.
And it has never ever completed ever.
Okay.
I set it to like thousands of failed repair series or blocks or
Okay.
tests.
Yeah.
And it doesn't matter, it always fails.
Okay.
But the point is that I'm very worried about, like, I don't know what you call it, like zombified data or whatever,
Yeah.
comes back to life, right?
So
But if
everything's TTL, that's not a concern.
it's not a concern.
Yeah,
Okay.
yeah.
Because like what's happening, I am like 99% sure that we dug our own grave, like whoever made the data model.
Yeah.
They thought it was like really clever. They're like, oh, we'll just session it, we'll just write it, the TTL.
Yeah.
And then as we like update the session,
Yeah.
they just rewrite the same record with a new TTL with
Yeah.
the same 20 minutes, right?
Yeah. Yeah.
So I feel like every single record goes in as a TTL.
Yeah.
So even if I don't complete repairs, it's still okay. Like nothing will come alive.
Yeah.
I just have tombstones.
Yeah. So if everything that you write is TTL, you can also set GC gray seconds to 0. Which I didn't fully explain GC gray seconds, but that's basically the amount of time a tombstone has to live, right? So the whole reason for GC gray seconds is to avoid zombie data. It's to give you enough time to run a repair and make sure that tombstone gets repopulated. If everything's TTL'd, basically that scenario can't happen. And so it's safe to drop GC gray seconds to 0 in that case.
We just gotta be like extremely certain. I gotta make the developer like sign in blood, like every single everything, always, forever.
Yeah.
In the time, every change we make will always be sure to include
Yes.
TTL.
Yeah. Either that or basically as long as you don't run any. Okay, so there's two things that you would want to make sure you don't do. One is you don't do any normal deletions, just like straight up delete statements. And the second would be you don't ever insert something without a TTL and then override it with a TTL. Those are the two scenarios. So the first one, the normal deletions, that's your normal tombstone problem. The second one is, if you inserted data without a TTL, and then overrode it with a TTL, but the overwrite didn't propagate to all nodes, and then those TTL records disappeared. The non-TTL version would still exist on one node, so it would still be live.
Right, and then whenever we repair it, it replicates out.
Exactly. Yeah.
You piqued my interest, man. So, are you telling me that if I write something with the TTL, and then I formally delete it, that it kind of like invalidates the TTL?
Yeah, I mean, if you delete it, it's immediately gone.
Oh, okay.
It's TTL.
Oh, okay.
Yeah, yeah.
But you said I need to avoid that.
Well, so if you've got TTL data, and then okay, so say you got 3 replicas, you write the TTL version that goes to all 3 nodes, and then you delete it, but it only makes it to 2 of them.
Okay.
And then say that that tombstone gets purged, the TTL version is still live and not expired yet on one.
Right.
Then it would
So just
come back to live for a while until it finally expires.
Okay, cool.
So it's not as bad of a problem,
Yeah.
but
Okay.
still something that
All right.
could
Well,
be.
that's a very thorough thing that you put in there. I appreciate that.
Sure.
That's awesome. Hey, I'm curious. Like, I know only a little about you.
Yeah.
How big? Like, when I drop my run this thing, do you know that?
I think I've heard it before, but yeah, there's like 450 people in the company.
That's like
So-
That's like everywhere, or that's like
It's
in
everywhere.
Austin?
No, it's very distributed. Austin only has like a dozen people. It's basically all engineers here. This is actually where the company started, but the headquarters back in like 2010 moved to the Bay Area. So we have an office out there with quite a few people, but we have a very distributed engineering and support team. So we have people all over North America, Europe, South America, Hong Kong,
Yeah.
Tokyo,
Like,
Australia.
I have like, I mean, I don't want to. If I tell you enough, like you're gonna think I'm like retarded or something because. Yeah, but I sort of like inherited this stuff, and I'm learning as much as I can as fast as I can.
Sure.
But you know, like all these tickets that I create, right? I have like people, like you said, I've got people in Florida that call me, and people all over me.
Yeah.
So it's interesting. All right.
Yeah,
Cool.
yeah. The support team, especially, is it's very widespread. So, yeah, Australia, Europe, and North America for those. So that's how we get 24-hour coverage on support. So, as far as the repair errors go, yeah, it's hard for me to say off the top of my head what that would be.
Yeah, I think we have like, I think everything's wrong.
Okay.
Like, I suspected like, well, anyway, I think we have a huge data model issue.
Yeah.
I think we have some tuning opportunities.
Yeah.
Like we had this dude, Kerry Law or something, came and like set us all up, supposedly. But then like, I think whatever they told that dude is not actually like the way that we actually used it.
Okay.
They're like, yeah, this is what we're gonna do. And then like, yeah, like, you know, and then they like tack all this other stuff on the side, right?
Okay.
So it's kind of like, yeah, you know, like, yeah, you need what you need is like, you know, like a Chevy Spark.
Right.
And then it's like, oh yeah, and by the way, we're gonna tow like this trailer.
Right.
That's like, you know, and then on the end of the trailer is like a Winnebago, and then like there's a Jeep, and it's like, you know, kind of like.
Right.
So,
Yeah.
all right.
Well, yeah. Hopefully your next session is useful then. Definitely, data modeling is something a lot of people have trouble with. I'm trying to get this gentleman's attention.
Oh.
I have an answer for his question, but
Oh, which one?
yeah.
Something.
Hey, I found what I was thinking of. I don't know if you've looked at this ticket, Cassandra 7272. It actually went in 2.0, but this is sort of the major compaction equivalent. There's also yeah, let's see here.
Our job to make sure the lights stay on.
Yeah.
Things work. And a lot of those people, like, it's not their core competence, right? Like, they build a ton of automation. Can't really pull apart now. There's using technologies that are meant to be certain ways, cache in the middle of it, and it's just all sorts of like, yeah, it works, but only through the grace of God kind of thing. So yeah, that's the
Is it like two dudes in the garage?
Yeah, I think it's just.
They had VC money, they were like.
I think it would just be no compact.
But it was a few people. And at the time, there was like really nothing. There was, you know, everything that was XMP, which old HipChat did. HipChat did.
Most of the people are from here.
There was,
This two of the guys I work with.
Link.
They're from, you know.
It's kind of a big
CCS.
patch.
Yeah, I mean, the two founders of
Whatever the
the
hell.
Yeah, it looks like it's
That
just,
was like Jabber face or something like that, right? So.
yeah, it's just,
Is Austin or?
It was not.
No, he still lives here.
it's the same way you would do any compaction with size tier, it looks like.
Yeah, he's got a house.
Basically become de facto for any tech.
I mean, the only way I know like to force the size tier is through JMX call.
Oh, just no
Not-
tool compact.
Import does it
Get people into
Yeah.
the company.
No tool compact, yeah.
Maybe you company would benefit
Yeah, that's,
from
yeah,
something.
that should be the,
I
just,
thought the node tool like the any like forcing compaction using node tool started from
True,
3.0.
but-
no,
Is
it's,
it?
it's been that way for a
Oh,
long
is it?
time, yeah,
Oh, okay. I
yeah,
thought it's only JMX. Okay, cool.
yeah, no, you can do it directly through no tool.
Okay, sounds good. But this is from 2.2.
Yeah, 2.2. So if you're using JS
2.18, we are 2.18.
Oh, 2.18, okay. Yeah, but yeah, you may wanna read this ticket just to figure out the details.
7272.
7272,
Okay.
and then, I think this other ticket may be,
One of our biggest customers.
related as well, let's see here.
And there's thousands. Well, they like having a room they call a pool party. Everyone.
Yeah, this one might also be useful, but it's 3.10. It's linked from 7272, but you may want to.
I think the tombstone compaction started, the tombstone only compaction, which only needs the tombstones. I think that
Yeah.
started from 3.8 or 3.10. I think that the other ticket you're talking about.
Yeah, there was one that, so originally it would just compact one SS table, and what this one's saying is, we should also try to include the overlapping ones, which is, that's the new behavior in this ticket, and that's from 3.10. So that makes it actually more useful.
Or whatever.
We are skeptical to upgrade to 3 dot because of the hints table, like the hints table change from table to
Yeah.
file, and then
Yeah.
what else we can, I don't know, we could. Actually,
Storage
like-
engine rewrite.
Yeah, so.
That would be a big
we-
one.
Actually, like, we upgraded like a year back from 1 dot something to 2.4 something.
Okay.
We had some problems, like.
Yeah,
with the
yeah,
connection.
yeah.
Okay.
So we had to
Condescending and snarky.
back off to 2.18. So like just that minor version itself, we had some problems. So we are now like if we go to 3 point something, like who knows what will happen.
I would recommend, if you upgrade to like, 3.0.8 or whatever the latest one will be at that point. But yeah, a staging environment, especially if you can replay
Back when I was talking about that.
your production,
Porn side.
writes against those. Like I don't know if you track like all incoming writes and it's something that you could replay, but that's super useful for staging environments.
Yeah, but as I said, like our problem is now tombstones. So if there are like bulk deletes happening, more like if there are more tombstones, the reads would suck, and then we want to clear those tombstones and we can't clear the tombstones. And
For LCS, the tombstones are more a problem in terms of the amount of space.
Yeah, of course, like we have like frequent updates, so we have to be on LCS.
Yeah.
Only the audit tables, history tables are using size tier,
Okay.
but otherwise the main tables all are on LCS.
But at that
Okay.
point in time, I
Yeah.
was just like, I did everything from the in-office shit.
It's kind of tough. It's like sometimes there are a few specific cases where it's not. You have to pick one kind of slightly non-optimal solution,
Yeah.
unfortunately.
So I read one guy like they are having a custom compaction strategy, which is on top of level. So whenever you choose SS table, everything like most of the behavior will be like leveled.
Okay.
But what they are doing is they're setting up a rules, like they have a separate table.
Okay.
They are saying that okay, so my
Yeah, no, I kind of like that.
so my row key, so for all row key, they're giving a range.
Yeah.
Long story short, it's just like.
So if there is a bulk delete and if they know the row key IDs, like
Yeah.
instead of like deleting and running a delete command on Cassandra,
Yeah.
like they're throwing that.
So the compaction just removes it instead.
Yeah. So whenever we are compacting, like whenever we are passing or like compacting, it will just not pick up this record.
Yeah.
And then just promote in the next level or like in the same level,
Right.
it will not pick up the record.
Yeah.
Instead of creating a tombstone and then deal with all these tombstones.
Are you talking about
What do you
what's his name?
I don't know. I read some.
Eric?
Eric, I don't know. Like I read
Yeah.
somewhere like
Yeah,
they're
that's who I was thinking of. I think we're talking about the same person.
Okay.
That's one of the 2 people that's ever done
oh, is it
a
Okay.
good
yeah
custom compaction strategy.
custom
Yeah, the other would be
It's not common, right, to use tools like
to do a custom one. No,
Yeah.
yeah. Jeff Giersa
In general?
wrote a time windowed compaction strategy as a custom one originally.
and then you guys
Yeah, and then we pulled it in.
nice.
So yeah, but he's a Cassandra committer now too. So it's like it's pretty rare. Yeah.
Which is like all of these.
But
so
you don't know
yeah,
anyone
so
like
yeah,
who's
probably
using
still-
such custom ones in production, right?
I can read-
Except for
This guy.
this other guy, which now I'm forgetting his name. I think
It's still like very
yeah,
much
I
confused
can
by
think of what he looks
David
like, but I'm
Becker.
forgetting his name. I bet he's on the Cassandra user mailing list, and I can find
I think
it.
after that, yeah,
Let's see
I
here.
was actually, so, don't ever let someone like promise you money to do a job that sucks. Because I was basically deviated from learning anything
Yeah, I
for
don't-
years to work in this job that was really just like, keep the lights on, like move us from 2000, like.
Yeah, it's
Eric
also on
server
his
and
GitHub
Microsoft
page,
server
so.
2000,
Yeah.
2008. And then
No,
like
not
a
that
really
Eric.
ancient old
Okay, I
spinning
can't.
disk
Eric
hardware,
Stevens,
and
maybe?
virtualized
Is that him?
Zen server stuff, and then realized I hate that, and you go back and develop. And then
Yeah,
I
Eric
started Python,
Stevens.
and I
I don't know if you've seen his name
Yeah,
before.
I don't,
Yeah.
I don't remember the name.
Yeah.
I didn't focus on the name.
Yeah.
Like, it wasn't like.
Yeah, he's the one that wrote
Oh,
one, I
okay.
think.
Oh.
I imagine,
Yeah.
like.
Yeah.
Nick, when you were in school, was Stack Overflow
Yeah,
a
so
thing?
we are having this problem and then
Must have been just brand
like we
new.
are trying to avoid these bulk deletes and maybe we should lower our GC grade, but which is not ideal for us.
Yeah.
Uh,
I feel like it was, I feel like every time I Google for something, you get expert.
Yeah,
exchange.
there's a.
all the reads are
No,
time
no,
exceptions.
I read everything. Expert
so
exchange is a paid for forum.
Have you read,
Or shit, like,
see here.
experts, right? Like,
I don't know if you use. So that there was that talk that I mentioned.
From the summit?
Yeah, from the summit.
That was a long time ago, but yeah, now it's like,
Yeah, I guess maybe,
Uh,
I guess maybe it was either really new or not around.
it's probably just coming out, to be honest, and it's like, and they're like a great example of like, everyone's crazy about like horizontal scalability, and they run
I
5
think
web
that's just
servers, and they
lost
serve 60 million page views a
Mm-hmm.
day. Yeah, they're legit, like, they redo their hardware,
Yeah,
they write a
it's-
paper up about it every year,
This
they're all
one?
about vertical scalability.
Oh.
Yeah, we have a
That was
Redis
a
server that
video,
has.
but this one-
like,
this is a very
300
detailed talk.
gigabytes of
Okay.
DDR4.
On level compaction.
You know, like, you can fit
And
our
it does
most-
talk.
our busiest tables
Talks more about
in memory.
tombstones.
It's
And
like-
it also links all the tickets that have
And
been
they're all .NET too, I
improvements.
think?
Okay.
Well, it's not all .NET, but I
so-
think they're, I think the app is, yeah, it's all.
I mean, I've
PHP
seen those
actually,
tickets
so,
too, but all are like 3.8, 3.10.
Yeah.
I mean, tombstones,
So I
exactly
think
like compaction
there's
for,
no right
just for
answer.
tombstones. It's
Yeah.
not a major,
What are you
it's
gonna-
just a minor.
Yeah.
Just
Oh, no,
clearing
no,
these
that's
tombstones,
that-
but
Yeah.
it's from 3.10.
10 years ago.
Yeah.
So even all these talks wouldn't help us
I was
Well,
up in
if-
unless we upgrade to 3 dots.
Yeah, if you're really desperate about it, a lot of the times patches for compaction strategies are easy to backport. Because the actual compaction strategies themselves don't really change. So
Oh,
if it's something that you really want, you might be able to
Look at the
backport the
code
patch
and-
yourself.
okay.
Yeah.
We had, we had like,
Dude, I got gyms, man.
So yeah, I'd recommend watching this talk and
Yeah,
going
sure.
through all the
I'll-
links as
I-
well, just to make sure.
Yeah, sure.
But yeah, it's missing manual for level compaction.
missing manual.
Okay.
Yeah.
Your operating system
Sounds good.
class actually
This
has,
helps, yeah.
like,
Cool.
hand
But yeah, I mean, backporting maybe we
Yeah.
should try, but again, like
Books
in
and-
production, like
you know,
should
like
we,
7
like,
words
because,
and
Yeah.
I mean, like, you know.
I
like-
know it makes it makes it.
I mean, maybe
honest,
it's
but-
better to just upgrade to latest Cassandra and then, you know, I mean, it's
There's trade-offs.
trade-offs, yeah.
Yeah.
There wasn't like really.
Right now, we don't have any like real motivation to upgrade.
Yeah.
Academic.
If that's
So-
the only reason, I would, if I were you, I would look at
Yeah, I mean,
backporting instead. But
Last 10
I
years.
think.
I'm a lot more comfortable backporting patches. I do that for my job, so
Nothing like
Yeah.
exposed
I don't know
to
if that's a
that.
fair-
It's like, it's like
Yeah.
half the reason I like.
fair evaluation or not.
I feel like that problem is interesting, but.
Yeah, where-
I don't
where are
know
you
if
at?
I like learning how to
Bazaar
use
wise.
Oh yeah, that's right. Okay.
Yeah.
Whatever.
Also, like we have a position at Bazaar-wise, like if you know anyone like who is interested, like working
Yeah.
on Cassandra, because you know we are a big Cassandra users.
Yeah.
So
I
you
would've
know
already-
Fahad, you know Fahad,
I
right?
wish I had
Yeah.
gone to school.
Yeah, he left Bazaar-wise. So
Oh, he did?
like, yeah.
Like
So
the
we have a
golden age.
Oh,
vacancy
man.
for his position now.
Okay.
Yeah. So like if you know anyone like who may be interested and
Okay.
yeah.
Okay.
just-
You kids got it.
Uh,
Cooler and cooler.
Yeah, I would normally
Yet no one
have already tried to hire them myself. if
What?
I did.
In data
But-
stacks?
Yeah, exactly. But there are, yeah, maybe some like ex data stacks people.
Yeah.
And then they, yeah.
I mean,
we can try and hire Nick. I don't know.
I mean, like we do like programming like all the bits, right? It's
Right.
not just Cassandra.
Yeah.
So like
Yeah.
people
Ran for about a month.
who might be interested in that and not just
Yeah.
working on Cassandra.
Right.
You guys are only on,
Nowhere.
Well, like Cassandra, yeah.
and the domain is Cassandra, right? But
Right.
our domain is different.
So
So.
8 for that?
Well, it's not.
Go on,
it's
what's
not
your name again?
actually-
You're actually leaving.
Taylor.
Yeah, nice to meet you.
Yeah.
Well, I met you before.
Yeah, but yeah.
I don't know. Take some time off to figure it out.
You
Yeah.
see, yeah.
Yeah.
You guys are.
No, I'm at Atlassian.
Yeah, Nick's setting it out now, so that's why I said you try and hire him.
Your replacement.
Yeah, we have a position. You know Fahad.
Oh, yeah.
Yeah.
He's getting a couple spots there.
Yeah, I know. So
He left his
he left Bazaar-wise. So we have a position to
You'd be the new.
So
Cool. Alright, sounds good.
Thanks for coming out, y'all. Nice meeting you, Tom.
thank you. Thank you for the talk.
Absolutely, yeah. Yeah, glad to enjoy it. Blake did tell you everything you needed to know.
So
I started to ramble a little bit towards the end, but.
Brand new stuff, right? I mean, I've read up enough about it. So, oh, no, so like I ask because like we're in the midst of like I would normally just say like, dude, just bucket your shit and leave it in size tiered compaction until we know like what the best window is that you expect to see.
Yeah.
The problem is things are like so far, like I'm talking about Uber over here. Like Uber is like they have this crazy use case, which is probably we don't need to plan for as much as we think we do, but it exists. And there's 10,000 people talking in a room, generating time series conversation. Oh, for some reason they don't need to do this. We can tell them no, but we let them. It's the only reason they haven't moved the slides. So we let them do this, and like, and today that all goes into a fucking Elasticsearch, like for better or for worse, right? So there is no like, people aren't scrolling back in history there, so that's fine.
Okay.
The problem is, I'm worried about that adversely affecting just the overall performance of the cluster.
Just doing all this crazy
Just
stuff.
just storing it to disk, right?
Yeah.
And we can worry about putting it into an index later.
Is this like, I'm assuming this is like bots or something, surely it's not 10,000 actual people.
It's 10,000 actual people that are not reading what they're saying. Yeah, it's just like a shit fucking stream of consciousness. And yeah, it's just like a joke, I think, to them, like, where it's like, join this room and just yell some stuff into it, like, I don't know. Because it's just like status updates, and then I think what they do is they call our API and then churn that out, and then to like some sort of, I don't know, some other data store that works better probably.
Okay.
Someone using Hitchin as a message queue or something?
Yeah, probably, fucking probably.
Posted message
It wouldn't be the
queue.
first time, we've had some really bad actors that we had to put a bunch of like, what we call the deflector shield, which is just rate limiting. But it's just like, what are you guys doing? Just like, people will try anything as soon as they get their hands on the
Like
server.
chat as a database.
Yeah, no problem.
Hosted server, hosted message queue.
Yeah. Have you has anybody made a Fuse file system? That's what I want to know.
No, I can't say that I haven't. Yeah, I tried to make Union FSs out of fucking different rooms full of bytes. That would be fun though.
Of course, this is first at 1,000, right?
But yeah,
One
I
workload.
wanna make sure it just works right, so like, I don't know, I'm sure it would be fine, we could probably make the window fairly large, I wanna say, but, cause like really what happens is you scroll back in history and you go and get the last 100 messages or whatever
Right.
the number is.
Yeah, you're not jumping back to.
No.
Well, even if we did, time window would be better for that than size tier.
Really? Yeah, I mean,
Yeah.
it seems that way, right? Like, the worst case I'm imagining is like, I make the window too small or something like that, right? And it's just gonna do a lot of pops or something.
Yeah, I
Too
mean-
big, maybe it's not.
Yeah, it would depend on your average like read slice, right? So if you're requesting like a day's worth of data at a time and your window is like 1 minute, then obviously it's gonna be really shitty. But even if, yeah, I mean, I would try to make the window as large as your typical read size or larger. If it's reasonable,
Okay.
make it larger, then just make it larger.
Yeah, I mean, I'm sure it'll be larger than that. I'm wondering, I mean, that's the thing, we did a lot of stuff that way because of the shitty decisions we made about our infrastructure, our data store, Elasticsearch.
Yeah.
And I'm like, why are we doing this? But that's just what we bought and we just never changed it, so. We had an outage right before Christmas and it was all because of, like Thundering Herd block contention shit in MySQL and then Elasticsearch falling over because, everyone makes the same request for the last so many, it doesn't fall over, but it just stalls. Everyone makes the same request to get, history for a particular index, which is time-based, so literally everyone is hitting the same index. It's 4 replicas or whatever, right?
Yeah.
Whatever.
Yeah.
Eat nonsense. Yeah, whatever. I mean, I think we're okay. We're running 3.7, we're in Cluster too, so
Okay.
like I don't have to ever do a thing anymore. I just have to make sure people aren't shooting themselves in the foot actively.
Nice.
Yeah.
Sweet, man. How's Instacluster been so far working with
I love it. I met up with Ben Bromhead and
Yeah.
other Ben.
Yeah, what is the other Ben's name?
He's nice, but he's a product guy. But yeah, we went out for drinks and shit, we talked and, they seem like they know exactly what they're doing, like they're gaming the shit out of AWS and the EDS volumes right
Yeah.
now. So when you get, they don't advertise this very much, they did their homework, but like you get their pre-sliced, instance types.
Yeah.
Or node types. The largest one, the bulk is like 1,600 gigabytes.
Yeah.
Of space, but it's broken up into like 8 different volumes.
Okay.
So you can maximize burst throughput for when you flush the disk. Yeah. So, but they use Docker to host the DB, and then they just mount those volumes into a mount point. I haven't noticed a serious problem yet. I haven't really put it through a stress test yet either.
Yeah.
But it works really well. And
Cool.
they have their own metrics thing. Like,
Yeah.
they used to just apparently wrap Ops Center and just put it in iron.
Yeah, I remember hearing
When we were partners, we said that was okay, but now we're not partners anymore, we tell them that to stop.
Yeah, so apparently now they use, what's Aethier's metrics thing, or Kevin? Riemann, yeah, apparently they just use Riemann to pipe metrics out and then render it in some bootstrap. I mean, it's all looks like Twitter bootstrap in their interface, but it works.
Yeah.
And they've made feature changes for us, like I need custom tagging because we have this crazy policy where if you're missing the tags, who owns this, it just, like something called Alfred comes in and turns it off.
Oh.
Yeah, we have so many people at this company that are just like, the whole jobs are to make it harder to do anything. Yeah, no, that sounds like fun. It's pretty good, it's not bad.